and in this tutorial we're going to speak about the execution context and the call stack. In order to make the entire subject more clear, we need to go to the very beginning and identify the starting point of our application. Between the script tags we have the global scope, and what happens here is really just we're actually inside the main window object here. It's just not being shown to us. In other words, behind the scenes, JavaScript does something like this. It instantiates the window object for the global scope. And that's pretty much what global scope is. It's an instance of the window object. Now, because we are inside the window object, if you try to output the this keyword in the global scope, you'll notice that it actually equals the window object. What's more interesting is that the window keyword itself, which was instantiated here, equals exactly the same thing. And so this is actually why you can do something like this and compare the this object instance with the window. It will actually be true because they're one and the same. And for the same exact reason, if you try to compare the alert function, for example, to window.alert, it will output true. And again, the same thing is here because this is actually the instantiated object that is exactly the same as window. Now, there's a lot more to the this keyword in any scope, including the global scope as well. So what this usually referred to as the this binding, and we're going to explore the subject in just a moment. Remember how in my previous tutorial we talked about lexical environments, and basically there were three different types of lexical environments. The block scope, which is just the brackets without any context. It's not a function, it's not global context. It's just the brackets you create anywhere and you can nest them anywhere in your JavaScript application. Then we have the global scope, which is really just the same as the window object we described here a moment ago. And the third type of lexical environments is the function scope. So this one's a little different, and the this binding can refer sometimes to the global scope in the function, and most of the time it's referred to the function instance itself. We're going to take a look at this in a little more detail in just a second. What is execution context? Basically, execution context consists of three different things. It's the lexical environment. Usually when we talk about execution context, the lexical environment we will be talking about will be either the global scope or the function scope. Execution context is usually not discussed in the context of block scope because it's just even though that there is a this keyword available in the block scope, just to describe the concept of how it all works, these two different scopes are used generally to explain that. And so we got the lexical environment. It's one of those scopes that we have just covered. Variable environment is simply a place where you create your variables. It evaluates the values of the variables you created. And one important thing to notice here is the variable environment is separate from the this binding. So for example, what I mean by that is when you create variables using var, that gets landed into the variable environment. Or the same thing for let, it still goes into the variable environment. But when you start messing with this keyword, you're dealing with the this binding. And whatever this object is bound within the given scope, in this case it's a global scope. So whatever that object is bound to in this scope is going to be accessed by the dot operator. And in different scopes, this keyword can be referring to different execution contexts. It's not always necessarily referring to the actual scope it's in. In order to demonstrate how it actually works, I'm going to switch to a visual diagram that I created that should explain this entire process in greater visual detail. And so, having said everything that we have mentioned so far up to this point, what is the call stack in JavaScript? The global scope is the very first layer of the execution context. So whenever your browser runs your application, the first layer of execution context is created by the window object, which is the global scope. Now let's say we create this function in the global scope and call it FA. Inside this function we assign the X property on the this object to 1. And so what happens here is that once we run FA function, because we're writing it from the global scope, this object inside this function will be actually equal to the global scope object. This is why after we run this function, we try to output x on the window object. Now we'll get 1. It's the same value we set here, because again, this keyword inside the function that was called from the global scope will be bound to the global scope, or the window object, and not the function itself. So in other words, what I'm saying is, inside a function, this object is bound to the context from which the function was called. In this case, it is window, or global scope. Usually, though, this is not considered as a good coding practice, because why would you want the inside scope of a function have any ties to a global variable? Usually, that's not a very good code design idea. But that's just how JavaScript works on this basic global scope level. What actually happened here is this new execution stack was created. And as you can see, again, because the function was called from the global scope itself, and that this binding will be equal to the window object, even inside of this function. Now, let's erase this example, and I'll show you something else. Let's use the this keyword in global scope to simply identify this space as global scope. And now let's create a object literal. And so in this object literal, we have a method here that will output the value of this a, which was defined right here. Now, in this case, notice how we have a variable a defined on this object in global scope, and we also have property a on the object literal. Now, in this particular case, because we're calling the method directly from the actual name of the object literal, the property on this object here will be evaluated to 1 and not global scope. That's because the method here was not called from the global scope itself. On the contrary, notice that here we created a new variable called m and assigned this object method that we have just called here. But notice that this method is created in the global scope. So what happens here is when we actually call the method m, the result of this operation will not be 1, it will be global scope. Because again, this method has been transferred into the global scope. So this context in this function will refer to the global scope variable defined by the global scope this instance rather than what we define inside the object literal. And this is happening because it was called from the global scope. But in this instance, because it's called from the name of the object that was created, it's no longer called from the context of the global scope. And for that reason, this keyword here and the property a is taken from the object itself. So in a way, it's kind of locked inside. It's private to this object in this case. When the execution of the script reaches this method, what's going to happen, actually calling this method will create another execution context added to the call stack. Once this method returns, though, it will disappear from the stack again. As execution continues going down the script, eventually we'll arrive at calling this function again, but this time from the global scope. And what's going to happen is that we will create another execution context once again. They will not be stacked one on top of the other, because as soon as this one finishes returning, it will disappear. There are cases where you can just build these execution contexts into the stack by continuing calling a function inside a function. And usually you will have several levels of these execution contexts stacked one on top of the other as the functions inside functions are being called. And of course, this keyword will continue being bound from whatever context the method was called. Now, you'll have a lot of cases like this where you have a function calling another function and it just keeps chaining the function calls. In this case, you will grow a taller call stack of all of these execution contexts. And one thing to notice here is because a, the first function, was called within the global scope, what's going to happen is you'll have a chain of this bindings all the way up to the function C, which is the last one to be called. And this function C will also, within this function, this keyword, it's chained all the way back to the original window object. Again, because it's called from the global scope. If you had functions, constructors executed using the new operator, then this chain would be broken. A new operator creates its own context. When you create constructors, they totally just own this object. And if you call any functions from that constructor, obviously they would inherit whatever that this object would be at that time. But if you're just calling functions within the global scope and execute them starting from the first one, then it goes into B and C and so on and so forth, you will retain the original global scope binding of this. So it's sort of like a chain created, and that goes all the way up to the number of functions that you're going to call. And that's pretty much the idea behind call stack and execution contexts that keep stacking up on the call stack. So thanks guys for watching my tutorial.